Okay, so welcome back to our course on game theory. And just in terms of an introduction, basically game theory is well suited to modeling situations where we have strategic interaction between players. So what does that mean? That means that we're looking at decision making, but decision making where one person's payoffs or the outcomes that they face really depend on what other people are doing. And so you can't really separate the decisions of one player from the decisions of another. So it's really well suited for understanding interactions where people have the ability to understand how their decisions are going to be affected by other people's actions. Obviously in this course we'll be working with models, and the idea in order to make things tractable is to somehow simplify and abstract away from some details. Of course that means that you're going to miss some important aspects of reality, but hopefully a lot of the analysis we'll do will be well suited for capturing some basic insights, and hopefully in some cases the essential insights of strategic interaction. So let's start by talking through a few examples of the potential applications that game theory has been used for. So just to throw some out, war, why do countries arm differently? So you see some countries which are very heavily armed and spend a lot of their GDP on armaments, while other countries spend very little. Tragedy of the commons, how do we structure international agreements in order to make sure that we don't deplete resources too extensively? How should the international agreements be structured? Markets, what will happen if we allow two companies to merge that are actually large companies and might come to dominate a market? E-commerce, so if you want to structure an online auction and want to maximize revenue, how should that be designed? How would you make sure that sellers are actually behaving themselves and delivering goods to buyers? There's lots of legal applications, so if you wanted to think about auditing somebody who's supposed to be paying taxes, how should you design your audits? Sports, so if you're a soccer player and you're thinking about trying to kick goal kicks, how should you choose whether you kick to the right or the left? How does it depend on how good the goalie is in one direction or the other, or how good the kicker is? So all of these are questions in which the decision of one player is going to depend on the decisions of other players, and really where game theory is designed to do an excellent job of making predictions. So let's get into a little more detail. So we've talked through some of the basics, and one thing to emphasize here is that game theory really provides you more or less with a methodology or a toolbox. So it provides you with a series of ways of thinking about how we can structure games, how we can model different players' decisions, how we model payoffs, and so forth. The specific tools are going to vary with the applications, and the course will take us through some of the more basic tools and the important ones that you see used in practice. Okay, so in terms of modeling games, there are different things that are going to be the essential ingredients that we have to keep track of. Most importantly, obviously, we have to know who the players are. And that's going to involve knowing who's making the decisions. So, if we're modeling a company, do we model it as a single person making decisions, or do we model it as many people? That's a decision we'll have to make. Strategies, what are the actions available to the players? So what are their choices? Timing, so does one player move before another player, so that one player gets to see what the other player's done before they make a decision, or do they both move simultaneously in ignorance of what the other person's doing? These are all going to be very critical in trying to understand what happens, and we'll talk in detail about some of these things as the course progresses. Information, so what do players know when they're choosing? So what kind of history have they observed? What do they know about what the other players' payoffs are? What do they know about their own payoffs? Payoffs, more generally, what happens as a function of actions? How do we describe who gains and who loses from different situations? And moreover, what motivates players? So what do they really care about in terms of their decisions to play a game? And ultimately, some of the most interesting parts of game theory are really going to come in trying to solve games. So once we have things written down, then we have to make predictions of what's actually going to happen. And there we'll have to have some way of predicting behaviors, and so we'll have solution concepts and different ways of thinking about making predictions of people's behavior in different settings. So in terms of a rough outline of the course, you can sort of break things into different parts. We'll start with what are known as normal forms. That's the most canonical structure of a game, where we'll represent things in a fairly succinct manner, and we'll start there. Now, extensive forms are, we'll look at game trees and more general formulations, but the idea behind an extensive form is it's going to keep track a little bit more explicitly of moves, who moves first, who moves second, who gets to see what before they move, and so forth. The third main topic we'll cover is repeated games. So there's many situations in which a given game is repeated over and over and over again. And when you're playing with the same set of players in repeated situations, that can change the incentives relative to what you would have done in a single situation. So we'll start by analyzing games in isolation and single rounds, and then we'll move to repeated games. And finally, one of the more important topics that we'll get to towards the end of the course is bringing in incomplete information into the setting. So most games that you actually deal with in the real world involve some degree of uncertainty in players in terms of what they might expect from other players, in terms of what the other players' motivations are, payoffs, what their own payoffs are. And so we'll talk about how we model incomplete information in a general way. Okay, so let's get started. So our first topic here is now the normal form games. And before we go through the formal definitions, it might be useful to just go through an example to give you some idea of the scope of game theory and to give you an idea of how this is done and so forth. And then we'll come back to some formal definitions after we've done this. The first example that we'll talk about is predator-prey games. And this is an analysis that's based on a paper by Chen Shi and Sheng Bao in 2008. And it's a very simple abstraction of strategies that might be used in animals between predators and prey. And basically it's going to distill things into a very simple form of game where a player, now a predator or a prey, can choose either to be active or passive. So let's talk a little more about what that is going to be. So the idea here is you can choose to either have an active strategy, meaning that you're expending a lot of calories, moving around quickly, or you can sort of sit and wait. So spiders you could think of as being a passive insect. Something like a lion that moves around and has to chase prey, that's going to be an active strategy. So they have the choice of being active or passive, and the payoffs that they get are kept track of in this formulation by just keeping track of the expected calories that they capture less the expected calories that they expend for the predator. So if you're active, what does that mean? That means you're going to expect to burn more calories as you're chasing prey around, but you also are going to expect to capture more. So there's going to be a trade-off possibly, and we'll have to look at that in detail. Now the prey, here the payoff is kept track of in terms of an expected penalty for death. So obviously you don't want to be caught by a predator, but also you burn calories if you're moving around actively. So the trade-off here is if you're active, you have less of a chance of being caught, but you're also burning more calories. So the important thing here is that the expected calories that you burn and the expected rate of capture depend on the interaction between the strategies of both the players. So let's have a look at how that works. Okay, so now in terms of making some predictions about what's going to happen in the predator-prey game, the first thing we can begin to do is look at the different payoffs that the predator gets, for instance, as a function of which choice they make. So let's have a peek at that. The predator here, if we look at whether they're passive or active, we end up seeing that if they're passive and the prey is active, they get 1.6, whereas if they're active and the prey is active, then they get 1.7. Right? So we've got 1.6 if they're passive and the prey is active, whereas they get 1.7 if they're active and the prey is active. So obviously it's better for them if they expected the prey to be active. We can do the same kind of analysis conditional on the prey being passive. So suppose the prey was going to be passive. What would the predator want to do? Well, they get 0 from being passive. They get 3 from being active. So again, we see a situation where it's better for them to be active rather than passive. And so what do we end up with? We end up with a prediction then that the predator should be active. Okay, so we have a prediction that the predator should be active regardless of what the prey does. So once we go to making a prediction that the predator is going to be active, then we end up having to look then at what should the prey do conditional on the predator being active. So if the predator is active, the prey gets a payoff of minus 0.8 if they're active, minus 1 if they're passive. Obviously, it's better to get minus 0.8 than minus 1. So they should choose to be active as well. So when we solve this game, what do we end up with? We end up with a prediction that both predator and prey will end up being active. Now, obviously, this is an abstract formulation where there's a lot of things that have been swept under the rug, but just based on some really simple calculations of calorie expenditures and simple strategies for predator and prey, we end up with a prediction that for large mammal games, according to the paper, that we should end up with both of them being active. Okay, so we could begin to ask ourselves, are most large mammals active? Well, you think about most predators you can name: lions, tigers, leopards, wolves, coyotes, etc., etc. Most prey, deer, antelope, zebras, and so forth, yes, they're active. It's not exclusively true. You could think of things like sloths or other kinds of animals that are quite passive. But we end up with a prediction that seems to match some things. So obviously we can enrich the game to take into account different kinds of habitats, changes in climate, changes in the particulars of the geography and so forth. That's going to enrich the game, but also lead to a much more complicated analysis. So for our purposes, this begins to illustrate what's going on. Let's take a look just at a quick variation on this, where instead of thinking of large mammals, now we think of small insects. So here are the payoffs from the same paper we talked about just a moment ago, but now readjusted for small predator-prey games where we're dealing with insects instead of large mammals. What do we see here? Well, now let's look at the predator's strategies again. So if the predator expects the prey to be active, then what should they do? Well, they prefer to be passive, because in this particular situation, active prey in an insect game are hard to catch. You'd be better off not expending too many calories, being passive. So now let's think about, well, suppose the predator was passive. What should the prey do? Take a look here. Well, they get -6 if they're active. They're burning calories. Since the predator is being passive, they might as well be passive too. They don't burn as many calories, so here they get a 0. Okay, well, if now the prey was being passive, what should the predator do? Well, we end up with a prediction that if the prey was really going to be passive, now being active really pays off. You catch a lot of prey, so you get 6 versus -1. That's a better payoff. So we're sort of moving around here. So now if the predator is active, what should the prey do? Well, when we go through the last part here, they get -8 if they're passive, -7 if they're active. So what have we got here? We've got a cycle with no particular pair of actions where both of them would stay put if those were the choices. So this is a game where we don't have any stable pair of strategies. The prey wants to match what the predator's doing, and the predator wants to mismatch. So we're going to have a game which actually is going to end up having to be solved using some randomization. So we'll come to that a little later in the course. This is going to be a game where what we actually see is some predators being active, some being passive, some prey being active, some prey being passive, and they'll balance each other to make sure that everything works out. And we'll talk about that in some details.